In section 8.6, we're going to be identifying special quadrilaterals. So really what this section does is just wraps up this entire chapter, being able to use the properties that you're given in order to identify what kind of quadrilateral you're given. So that being said, here is the quadrilateral family tree. So we start off with any kind of quadrilateral. So we have a four-sided figure. Stemming off of that, we have parallelograms. Remember, parallelograms have two pairs of parallel sides. And then stemming off of that, we have rectangles and rhombuses. So remember, a rectangle is a parallelogram with four congruent angles, and a rhombus is a parallelogram with four congruent sides. And if I put those two ideas together, I would get a square. So a square is a parallelogram that has four congruent angles and four congruent sides. Another type of special quadrilateral is a trapezoid. Remember, that means I have exactly one pair of parallel sides. And then stemming off of that, we have isosceles trapezoid, which is just a trapezoid with the legs congruent. And then finally, we have our last special quadrilateral, which is a kite. A kite has no pairs of parallel sides congruent, but has two pairs of consecutive sides are congruent. But remember, opposite sides cannot be congruent. Otherwise, it would just be a rhombus. So this is the quadrilateral family tree. You can also Google quadrilateral family tree and come up with a lot more elaborate family trees if you want something else to be put in your notes. So let's look at example number 1. It says STUV has at least one pair of consecutive sides congruent. What types of quadrilaterals meet this condition? So let's first think about our parallelograms. We know in parallelograms, opposite sides are congruent, but not necessarily consecutive sides are congruent. But thinking again, going down our quadrilateral family tree, we have rectangles and we have rhombuses. Well, in a rhombus, all four sides are congruent. So that means we would have at least one pair of consecutive sides congruent. Remember, consecutive means that they are touching. So again, a rhombus would satisfy this condition. And if a rhombus satisfies this condition, so would a square, since you would have at least one pair of consecutive sides, meaning they're touching, that are congruent. And now moving across our quadrilateral family tree to trapezoids. A trapezoid has one pair of parallel sides, and then the legs can be congruent or they cannot be congruent. It just depends on whether or not it's isosceles. Sometimes one of the parallel lines might be equal to one of the legs, but that's not always going to be true, so we cannot state that is going to be true for all trapezoids. So we're not going to put trapezoid down. Let's move over to kites. Well, by definition, a kite has two pairs of consecutive sides that are congruent, so therefore it has at least one pair, so our last answer would be a kite. Example number 2, is there enough information given in the diagram to show that quadrilateral ABCD is a square? So notice that it gives us that these three angles are 90 degrees. Knowing that a quadrilateral has 360 degrees, if this is 90, this is 90, and this is 90, so 90 plus 90 plus 90 is 270, 360 minus 270 is 90 degrees. So we do know that angle C is 90 degrees. If I have a quadrilateral with four congruent angles, I have a rectangle. Since it's a rectangle, I know it's a parallelogram, and in a parallelogram, we have opposite sides congruent. So if this side would be congruent to this side, and this side would be congruent to this side. And since we knew that originally AD and DC are congruent, that means that all four sides are congruent. If all four sides are congruent, that means we have a rhombus. And if I have a rectangle at the same time that I have a rhombus, then that quadrilateral is a square. So yes, there is enough information to prove that quadrilateral ABCD is a square. Example number 3. What is the most specific name for a quadrilateral for each quadrilateral? So we're just going to name them as specific as we can. So here's part A. First thing I noticed that the diagonals are bisecting each other, since this segment and this segment are congruent, and this segment and this segment are congruent. So I at least know that this is a parallelogram. But then I also noticed that all four of these segments are congruent, meaning that this segment is congruent to this segment. Therefore, we have a theorem that states that if the diagonals of a parallelogram are congruent, that parallelogram is a rectangle. So even though that this looks like a square, we don't have any information to prove that all four sides are the same, so the most specific name for this would be a rectangle. Moving on to part B. First thing I notice is that we have two pairs of consecutive sides that are congruent. So therefore, this would be a kite. Problem C. The first thing I notice is that I have one pair of parallel sides. So I know this is at least a trapezoid. My next thought is to decide whether or not this is an isosceles trapezoid. And an isosceles trapezoid, the diagonals are congruent. But in this situation, we do not have diagonals that are congruent, so therefore our best way to describe this quadrilateral is as just a trapezoid. And now on to problem D. The first thing I notice is that I have one pair of opposite sides that are congruent, but I don't have a second pair. So my initial thought was maybe that this is a parallelogram if I knew that this side was also 9, but I don't. I also see that this diagonal is being bisected, but I don't know that this diagonal is either. So therefore, I don't have any conclusions I can draw from the diagonals. So since I don't have any specific solid information to prove that this is a specific quadrilateral, the best way I can name this is just as a quadrilateral. And that's it for this section. Make sure you jot down anything you don't understand that we can cover in class, and we'll see you then.